Good morning to one and all. Today's topic is related to electrical stabilization. Once again, we have to recollect a few points from previous classes regarding this stabilization chapter. And that means the total stabilization is entirely divided into 10 categories. In those 10 categories, first one is entirely different and related to mechanical stabilization. That means some quantities of mechanical equipments we are utilizing for the purpose of stabilization. And next, second one is related to this lime stabilization. It is a one of the chemical. The composition of the lime normally we are using is CaO or CaOH twice. That means if without water it is CaO, with water it is CaOH twice. And next, third stabilization we are utilizing is cement stabilization. In the cement itself we are having different grades of cements and types of cements according to the structure and utilization. We are using the quantity of cement and quality depending upon the usage of pavement and load conditions. Next, fourth one we are discussing about chemical stabilization. In the chemical stabilization we are mainly focused on salts, means calcium chloride or potassium chloride and this sodium chloride. Majorly these three salts are used for the purpose of stabilizations. Normally these salts are entirely these salts are normally dividing into two categories like ionic matters, positive ions and negative ions. Those ionic matters will forming a crystallized bonds with the surrounding particles, so that there may be generation of some crystals, so that the crystals are entirely responsible for giving load, and that means giving strength and stabilization. After the after this chemical stabilization we are having fly ash stabilization. In the fly ash stabilization, totally thermal power plant waste. The thermal power plant waste normally we are obtaining day by day in huge quantity, so that simply we are using this thermal power plant waste or fly ash as a binding material to improve the strength properties of the soil. Why? Because this fly ash is obtaining in very cheap, and everywhere we are obtaining fly ash nowadays. Why? Because moreoverly every district we are having this thermal power plants or any other coal based waste materials. All those are comes under this fly ash condition, so that this fly ash is utilizing for the purpose of stabilization. After the fly ash we are having a rice husk ash. This rice husk ash also we are obtaining in a more quantity. Why? Because moreover the people utilizing this rice as a feeding material, so that uh, for the purpose of removing this total top layer of the rice grains we are getting this rice husk. And after burning those rice husk for the utilization of hotels and other utilities, we are getting this ash, so that we have to utilize those rice husk ash also as a stabilizing agent. After that we are having bitumen. Normally this bitumen is a waste material which are getting from destructive distillation of these petroleum products. Normally petroleum we are obtaining from other countries, so that after destructive distillation of petroleum, in the last stage we are getting this bitumen, so that we have to utilize those bitumen for purpose of construction of roads, especially these flexible pavements. So that in some of the cases this bitumen is associated with some quantities of cement and other cutback bitumen, and other fly ash content is added to this bitumen to stabilize the soil for the purpose of smoothness of the top layer. After this bitumen we are having thermal stabilization. That means in the thermal stabilization we are having two subcategories, heating stabilization and freezing stabilization. In those two conditions, whenever there is a huge quantity, a less quantity of water, automatically due to this heating, the total water will be evaporated. But in case totally against to this content of water, that means huge amount of water is there, automatically those water we are removing by using this, not removing those water, we are simply freezing by using freezing techniques with the help of some chemicals or inerting, that means inserting into the holes at a huge amount of pressures. Automatically those chemicals are simply freezing and the total water will be in solid state, so that there will be no movement of water, there will be no erosion process, no segregation. Automatically the total soil will be strengthened. Next content is electrical stabilization, today's topic. So that we have to observe, why, because what are the different processes, how this process will work. We have a clear cut idea about those previous process and today's process. Today's process is entirely related to electrical stabilization. In this electrical stabilization, we are using power. Normally in the second chapter, electroosmosis, we are studied. In this electroosmosis, simply we are giving direct current to the earth. Why? That means to remove the content of water. Likely here also we are using electrical stabilization for the purpose of removing water content. Moreoverly, these two topics, electrical stabilization and electroosmosis, both are related to same and used for also stabilization of the soil, but some slight changes are there in case of electrical stabilization and osmosis. Those things we have to discuss here in a brief manner. First of all, electrical stabilization is generally done by using one of the known methods of electroosmosis. That means previously we discussed about this electroosmosis. Likely here also it is a famous method for removing the content of water whichever is present in the beneath layers of the earth. Here also this electrical stabilization is conducting by utilizing the principle of electroosmosis. The same principle which was used in the electroosmosis, that is implemented in here. After implementation of this electroosmosis principle, automatically the total water will be strengthened. When a direct current is passed through a clayey soil, that means normally clayey soil is very fine in nature. These fine soils are simply capable to catch more quantity of water, less quantity of water compared to these coarse grain particles, so that somewhat of the water is there, those water will not be removed easily. Why? Because the total soil particles are very fine in nature, so that removal of water will be takes at higher costs. To neglect those higher costs, we have to simply implement this electro osmosis principle here. Normally in the previous cases of dewatering techniques, we are utilizing different engineering principles to remove the content of water in coarse grain and fine grain particles. Why? Because in the coarse grain particles and fine grain particles, we are having some content of voids between the particles. Why? Because their granular size is very much large compared to this fine grain soils or clay soils, so that there may be some gap. In those gaps there may be stacking of water, so that we are using different engineering principles like slope and other cambers are were maintained. Due to those maintenance of slopes and cambers, automatically by the action of gravity, the total water is collected at a points. From those points, we are using these boreholes. From the borehole, simply we are collected the water from the soil, so that the total water whichever is present in the soil will be removed by the help of principles of engineering. But in case of clay soils, this is not possible. Why? Because the clay soils are very fine in nature. Due to their fineness content, the boreholes inserting is very costly process. On the other hand, there will be no movement of water. Why? Because particles are bonded together in a high content, that means in a high content the particles are bonded together. Due to those huge amount of bonding of particles, automatically water will be staggered at different points, so that there will be no movement of water. Simply the total water is staggered at different locations according to the layers, that means according to the layers of the ground. So that simply we have to utilize this electrical stabilization. There is no other alternative method for removal of content of water, so that we are simply depending upon this stabilization method, which is related to electrical power. Here simply the current is passed through the clayey soil, and pour water is transferred towards the negative electrode or cathode. That means whenever we are transferring this current, normally current having two poles, positive and negative, likely cathode and anode. Those things are technically termed as cathode and anode. So that whenever we are transferring this DC current to the earth, automatically there will be formation of anodes and cathodes due to their charges. That means positive charge and negative charge. The total water will be collected at a one anode. That means that one anode to cathode. The anode will repels the water simply on the other direction. The cathode will attracts the water. Due to those attraction principles, so the total content of water whichever is present in the soil is collected at this electrode, likely cathodes. So that simply at that particular point we need to dig a hole and we need to remove the content of water, so that it is very easy whenever we are going for stabilizing the soil with the help of electrical power, especially in clay soils only. This change is generally happening due to the presence of positive ions. That means whenever a substance is there, automatically the substance is formed by bonding few particles, like positive particles and negative particles. Both are simply attracting each other. Automatically there will form some ions. That means not ions are simply attracting each other. After the bonding, the automatically those will form as a particles. Simply a huge amount of particles will collect as a, that means will stagger as a matter. Those matter now we are observing as a soil or any other material. Like if it is a wood, automatically there may be yeah, some matter. In wood also we are having some matter that is related to organic content, but in case of soil it is also one matter which is having some chemicals. If it is a red soil, there is hematite or magnetite. If it is a black cotton soil, so montmorillite, alite, likely we are having different chemicals in the substance, and other ionic matter also is there. Due to the action of this cathode and anode, automatically those ions will charge and they will act as cathodes and anodes. Simply they will transfer the water from those points. And due to the removal of water, the strength of the soil is considerably increases. Whenever there will be a removal of water on the structure, automatically the structure will be densified. That means normally in the previous case there may be some small content of water. Due to those content of water, automatically there will be some slight change in the structure of the soil according to the particle sizes. So that due to this water content, automatically the total structure strength also varies. Whenever we are removing this content of water from the soil, automatically there may be some decrement of voids and increment of plastic properties and shrinkage properties. That means shrinkage will be obtained whenever there is less content of water in the soil. So that definitely we are getting some quantity of strength to the soil after removal of this content of water. Next one, electroosmosis is also one of the costliest method of soil stabilization method. Why? Because simply we are giving a direct current to the earth, so that current is also one of the costliest item. Why? Because for every unit we need to pay some quantity of money. If there is a single unit, for single unit we are simply paying 3 to 5 rupees according to different institutions. That means different bodies we are paying money in the form of different charges. If it is a normal house, we have to pay 3 to 5 rupees. If it is a hotel or commercial complexes, we have to pay another quantity of money. If it is a institute, we need to pay another amount of money according to the place and its usability. We have to go for different charges, so that we have to focus on these electrical bills whenever we are doing this kind of stabilizations. Soil stabilization method also mainly used for that electro osmosis technique is mainly used for draining of water in cohesive soils. Cohesive and non-cohesive two types are there. Non-cohesive means automatically particle size is more, it is non-cohesive. Cohesive means particle size is very less. In this case of soils, simply we are employing this electro osmosis technique to remove the water. Incidentally, this method is also improves the properties of the soil. Incidentally, that means a small amount of the percentages of soil will be strengthened because of utilization of this electrical osmosis techniques and electrical stabilization techniques. Why? Because if there is no proper charge in the particles, automatically there will be no bond between them. Why? Because normally for strengthening of a structure, automatically there may be some bonds will be developed between atoms. Then only we will get a good quantity of strength. If there is no bond, automatically whenever we are applying a small quantities of the load, the total soil will be breaks into a number of parts. If there is a bond, automatically it will bear huge amount of loads. But in case of electrical stabilization, we are directly giving some quantity of current to the structure, so that the structure will absorb those current and the total molecules will getting charge. Due to those charge also, there may be some bond formation between the atoms and ions or metals present in the soil. Due to those also, incidentally there may be some quantity of change in the structure. Due to the structural change, automatically we are getting strength to the soil. That is the advantage whenever we are using these electroosmosis techniques. Next, in stabilization of geotextiles and fabrics, it is another method. Simply we are utilizing these geotextiles and fabrics. Normally geotextiles means textile, it is related to completely a dress or any other mat any other matter. That means normally in our daily life we are wearing a cloth. A cloth is also a textile. So that here we are using a term geotextile. That means simply we are giving a cover to the earth, so that simply it is a geotextile. Why we are using this cover means automatically normally to protect our body from external environmental conditions. We are using these cloths and textiles. Here also we are using geotextile term. That means these geotextiles are simply protecting the surface of the earth or body from external environmental conditions like wind, water and other temperature conditions and erosion, denudation and other uh, physical parameters and disturbing parameters to the top layers, so that these geotextiles are using to improve the strength properties and stabilization properties. Normally I will give an example. We are going to improve the strength of the soil, so that we are doing some of the densification methods for improving the stabilization of the soil. After 2 to 3 years, there may be some action of natural climatics. That means this action of huge amount of temperature or huge amount of floods or huge amount of wind force are acting on the structure. So due to those forces, also there may be some decrement of strength of the soil. To overcome those kind of situations, simply after the densification is over, we have to go for this geotextile process. Why? Because these geotextiles are directly responsible to bear those loads and divert those loads and conditions. Likely, we have to go for these geotextiles and fabrics for a long period of stabilization time. That means the stabilization is responsible for 5 years or 6 years. Whenever we are going to these geotextiles and fabrics, automatically their stabilization period also increases. Once again, we have to discuss a few points related to these geotextiles. Normally, how these geotextiles are made. Geotextiles are made from porous synthetic materials. Normally, porous means there may be some gap between the layer to layer or particle to particle. Those we are called as a porous structures. And synthetic materials, they are using term synthetic materials. That means the synthetic materials are normally a polymeric and plastic materials. Those are not directly mixing into the earth for a large period of time. Normally we are observing these polythene covers. Those are also a synthetic materials, but in case of these polythene materials, those are not degrading. Why? Because their structure is entirely different comparing to organic materials, so that those are simply inorganic and those are not degrading into the earth for a long periods of time. We have to catch that point. That means those are not involving or reacting into the earth, so that those are responsible for huge amount of period of time. So that we have to use those kind of polymeric materials for the purpose of stabilization of the soil. And such as polythene, normally polyethylene, it is a polymeric material. And next one, polyester, it is also a polymeric materials. And nylons, it is the one kind of plastic thread nylons. And PVCs, that means polyvinyl chloride. Normally in our construction works, most of the pipes are made up of this polyvinyl chloride. Why? Because this polyvinyl chloride will not react with the water, so that there will be no bond breaking. If we are simply using steel pipes or alloy pipes or iron pipes, automatically water will react with the iron and those iron will be formed as a iron FeOH twice. That means iron hydroxide, so that it will be breaks the total structure. After 5 to 10 years, simply we are going for refitting the pipes and plumbing work. Whenever we are using these PVC pipes, automatically those are not reacting with the water. Similarly, those are having some quantity of high strength, and those will bear huge amount of water pressures, and they will give long period of service life to the structure. Here also, in the purpose of stabilization, we are using these polymeric materials like PVC, polyester, nylon, polythene, so that those are also responsible for giving a long period of service time to the road or any other soil or geo profiles. That means geo profiles, GEO, that means related to ground profile. Next one, there is a different varieties of geotextiles. That means in the textiles itself there are different varieties. First one is like woven and non-woven comma grid. Normally woven, non-woven and grid, these three are the different materials related to these geotextiles. Normally whenever we are observing a cloth, in that particular cloth the arrangement of these threads will be in a different manner. If it is a polymeric polyester cloth, automatically the arrangement is different. If it is a cotton cloth, the arrangement is different. Likely here also we are using a different varieties of geotextiles for the purpose of stabilization of the earth. Likely we are having woven geotextiles, non-woven geotextiles, and grid geotextiles. Those three are different in their properties and arrangement of the threads. This geotextile materials are generally having a high strength. Why? Because those are related to polythene. Normally polythene having high strength, that means a tensile strength it is having, not a compressive strength. These polymeric materials are having high tensile strength. Whenever we are applying compressive strength, automatically those will plastic is a brittle material, so that it will breaks. But in case of tensile strength, it will be having huge amount of tensile strength compared to other materials. When geotextile properly combined and embedded in the soil, which will be contribute to its stability. As previously we discussed about these stability principles. Normally for different materials are simply keeping in the ground automatically due to the action of this content of waters and other surrounding chemicals. They will reacting with the surrounding chemicals and contents of water. Automatically those properties of the materials will be simply losing. But in case of this polymeric materials, they will not react with the particles or water naturally. Why? Because those are made in artificial manner. There are synthetic materials, so that their reaction is not possible at a normal temperature. At high temperatures only those will respond for reaction process, so that those are having contribution of stability to the structure for a long period of the time. It is a main advantage regarding to this polymeric stabilization. This type of soil stabilization method is generally used for the construction of unpaved roads over soft soils. Normally, paved road means there may be a top layer. Paved roads means normally we are having two major quantities of roads. Those are flexible pavements and rigid pavements. Those two flexible pavements and rigid pavements are paved contents. That means normally pavement means a layer which is constructed on the soil, which is useful to carry the vehicles, and which is not responsible to non-degradation properties. Normally whenever the vehicle is moving, automatically due to the pressure created by the tires of the motors, automatically the top layer will be eroded day by day simply. So that whenever we are giving these pavements, those pavements are responsible for non erosions. That means there will be no erosion takes place whenever the vehicles moving on the surface, so that those are simply acting as a pavement. That means the total pavements are skin to the structure. The skin is protecting us from surrounding atmospheres. Likely the pavements also protecting the layers of the earth from this movement of vehicles. But in case of these stabilization methods, those are responsible for unpaved roads. That means whenever there is no pavement like concrete or this bitumen, these polymeric materials are responsible to construct. That means we have to use these polymeric materials for the purpose of utilization of top layer as a road surface. And especially these methods are employable in soft soils. Why? Because soft soils are automatically their particles are very finer in nature. Due to those fineness of the particles, these plastics having a binding property with these finite particles. If there is a coarse particles, automatically those coarse particles will separates from these geotextiles. Why? Because coarse particles is a entirely different property, and this polymer having a different property, so that those two are not mixing each other. By the application of load, simply they will bifurcate easily. That means simply they will having a tendency to overlap on the each other, and whenever load is applied, automatically the materials will be skipped from the surface. But in case of these soft soils, whenever we are applying load, automatically those will be compressed to the structure of the top layer, so that there will be no removing of the top layer. Next one, reinforcing the soil by geotextile materials or metallic strips and providing the anchor or tie back to the restraint for the facing of skin element. Normally skin element means this pavement we are called as a skin element, so that this reinforcing the soil by geotextile materials. Reinforced earth we have to observe in our national highways. In the national highways, whenever there is a construction of bridge, means underpass is there, automatically on the underpass and overpass we have to observe this reinforced earth structures. In the reinforced earth structures we are having these facing elements on both sides of the road, so that those facing elements are simply tied together with the help of these tension wires. On the tension wires are simply immersed with this fly ash or any other industrial waste which is cheaply available in the localities of this structure, so that this reinforcing soil is formed likely. And the above the reinforcement of the soil, simply we are using these geotextile materials and metallic strips for providing anchor to the tie. In some of the cases, simply we are using these geotextile materials to control the erosion also. Why? Because those will not absorb the water content whichever is coming from the atmosphere, so that those water will not be allowed through the soil, by the soil, whenever there is a geotextile coating to the structure, so that it will also controls the watering techniques to the structure. And simply those will act as a skin element to the structure. Simply our skin in our body, the total skin is there, it is responsible for giving such quantities of facilities to our body. Likely this geotextile skin also responsible for giving some protection to the road surfaces or earth surfaces from external environmental conditions. Past research has shown the load bearings and strength of subgrades and base course of the soil materials can be improved through this addition of the biodegradable reinforcing materials such as fibers, geotextiles, geogrids, and geocomposites. All these things we have to discuss in sixth chapter and fifth chapters. We are having these geotextiles. We have to discuss these things in a elaborate manner. Why? Because we are having a plenty of examples with pictures, so that those pictures will dictate you as their composition and arrangement of the structures. Like fibers, how we have to utilize these fibers in the purpose of construction of the road. And the second one is the geotextile, how we have to arrange this textile matter on the surface of the earth. Next one, geogrids, how we have to protect the slope of the earth by using these geogrids. Next one, geocomposites. In the purpose of embankments, we are using these geocomposites for slope stability purpose. These four are the major materials we are using in polythene in the place of polymeric materials. Some of the past research has shown that load bearing and strength of subgrades and base courses of the soil materials, all those are the different structural properties. First of all, load bearing capacity, it is a structural property. It entirely depends upon the properties of the, that means properties of the material which was involved in the soil, so that the total arrangement of the particles also depend, having a tendency of this load bearing capacity. If the particles are well arranged, automatically load bearing also very high. There is no proper bond between the particles, load bearing also very low. Likely strength of the subgrade, normally whenever we are going for constructing a road, automatically we are using these rollers for densifying the soils and subgrades of the roads, so that the strength of the subgrade we will obtain whenever there is no void content and there will be no entrainment of water. Normally these fibers geotextiles will give a protection coat to these subgrades and embankments for that means non-entraining of water. Those will not allow water content to the structure. And the base course of the soil materials also, that means the top layer also responsible for this strength improving criteria. So that these four materials are majorly responsible to improve the strength for a long period of time. These materials can improve the quality and durability of the future highways and may reduce the cost of construction. That means majorly we have to focus on cost of construction. Nowadays, huge amount of money was investing for the purpose of construction works simply by using this cement and other uh, thermally. That means those cement and other binding materials. Those will cause huge amount of pollution to the environment by releasing these gases. That means those are simply toxic gases. Whenever we are going to utilize this geothermal, that means geotextiles, automatically those geotextiles are responsible to huge amount of years by providing a solid coat to the structure, so that we have to reduce the money and repair works whenever we are going to utilize these geotextiles. These materials can improve the quality. That means quality means automatically there is no entrainment of water, automatically quality may be improves. There is no entrainment of any other voids, automatically quality also improves. Those two conditions are maintained whenever we are utilizing these geotextiles to the top structures. That means especially for roads. And durability also improves. That means durability means against these environmental conditions those will not react. Why? Because those are polymers. At a normal temperatures polymers doesn't react with chemicals. At a high temperatures only those will having reactive phenomena. At present, lots of research and studies are going on these materials. Why? Because we have to recycle. Simply, 3R's principle is there. That means in those 3R, reduce, reuse, and recycle. Those three principles we have to implement in our construction works. Otherwise, we need to face a lot of that means we need to face a lot of money onto the projects. Why? Because simply we are consuming the materials, automatically after few days the cost of materials will be very high, so that we need to reduce the project cost simply by replacing with different waste materials which are coming from industries. Likely this polythene also we are getting tons of polymeric materials in our daily, likely polythene covers and pet bottles and other different covers like oil covers we are getting. So that all those materials we have to utilize in a proper way, and we need to design a new things which are responsible to the future. And those will be conducted in the laboratories, and they are having only partially complete. That means going on these materials based on the tests are conducted. That means elongation test and compressibility tests and temperature controlling tests. All those tests are we have to observe in a laboratories, and we have to give some quantities of additives to improve those tension properties and compressive properties to the polymers. Detailed study and practical research are essential for the future use of these geotextile materials. A detailed study means we have to go for A to Z. That means point A to point Z we have to study. After the complete study is over, we will having a clarity on the material. Then only we have to use those materials in different fields. If it is a row, if are normally nowadays we are using these geotextiles in the fields of roadways. After few years we have to utilize this principle to construction works like buildings and other conditions also. Why? Because the total buildings are degrading due to this chlorofluorocarbons and other chemical toxins coming in the atmosphere. So that these geotextiles we have to utilize as a outer layer to the structure to give a huge lifespan to the structure. Next, last thing is the recycled and waste products. How we have to utilize these recycled and waste products in our densification techniques. There are a lot of waste materials in the world, and there will be no proper disposal. Such materials are simply crushed onto the old asphalt pavement, likely copper and zinc slag and paper mill sludge and rubber tire chips, and essential to develop the proper and effective stabilization method. Why? Because in our daily utilities we are using and simply throwing a different quantities of materials in our household purpose. Normally whenever there is a repair to our fridge, automatically we are simply uh, getting a new fridge, and the old fridge we will send it as a waste material. So that in our fridges we are having different components in the form of steel, copper and other plastic materials. All those materials simply we are throwing as a waste materials, likely televisions and other air coolers and different things we are utilizing in our house for different purposes. Likely all those materials after their lifespan simply we are throwing as a waste materials. Whenever we are throwing those materials as a waste materials, after few years the total waste will be very high in our country. So that to decrease those content of waste materials, simply we have to replace those waste materials in different fields. That means if there is a construction work, for the purpose of construction work we need some quantities of steel and some quantities of plastics and some quantities of other materials. So that in those places of those materials simply we have to employ these waste materials for the purpose of filling and crushing, likely different purposes we have to utilize different materials according to their chemical properties and physical properties. So that simply we are using nowadays we are using these waste materials like crushed old asphalt pavements, comma, copper and zinc slag. Normally copper slag and zinc slag we are obtaining from industries of copper and zinc. After the manufacturing of these two materials is over, the slag is coming as a waste. Those waste we have to fill as a embankment to the roads and railways also. And the paper mill sludge, these thing also we have to utilize in the purpose of filling of the road. That means road purpose we have to utilize this paper mill sludge also. And rubber tires and chips, we have to utilize these rubber tires and chips in the form of production of embankments. Normally we are simply giving a trench to the structure. In the place of steel trench and others we have to utilize this rubber. Why? Because it is also a some elongation property. So that this rubber also we have to utilize. And simply tires we need to utilize those tires as a small pots for planting trees around the national highways. Those are also having one advantage. Likely we have to observe and we have to implement different things, and we need to improve our environment without any damages. These are the service needed to recycle hazardous materials. That means there are a service need to recycle the hazardous material. That means hazardous materials means those are very dangerous to the environment. Whenever there is a free expose to the hazardous materials, automatically those will react with surroundings, and simply they will pollute. So that we have to take care those things, and we need to recycle in a proper way. It will be necessary to develop a realistic, that means we need to create some realistic ideas, and those ideas will be developed in a very good and knowledgeable conditions only. Otherwise, those will leads to huge amount of damage conditions. And second one is the next one is the economical conditions. Also, we have to observe whether it is sufficient or not. That means how much cost for a new project, how much cost for second project. That means whenever we are using a project with a total material, how much amount of cost will it will takes. Whenever we are using those waste materials to construct a project, how much amount of cost it will take. So that both cases we have to observe how much amount of money we need to spend. If the money spent is very less for second project, we have to simply go to the second project that is related to waste materials only. If the total, simply we have to observe in both conditions whether which one is better and which one is having less quantity of money. Those things we have to design. And effective means of assembling the risk of pollution possessed by these materials to the localities and emissions. That means whenever we are using these waste materials, so that those waste materials are not responsible to give further emissions to the localities or bodies. Why? Because if they are simply giving a further emissions, automatically due to those emissions also there will be some decrement of lifespan of the structure. So that we have to focus on these localities and emissions coming from the waste materials. Okay, today's class is over.